Alrighty guys, welcome. I'm going to go ahead and get going on this homework here. Kind of zoomed in. I'm going to change the audio up and see if it has improved anything. Here we go. So on this very first one, hopefully it's not too bad. We need to subtract 6 on both sides. I'm going to try doing these problems in different ways, sometimes vertically, sometimes horizontally, to see if it makes any difference for you guys. Try them in different ways. So in this question, we're going to subtract 6 on both sides. When we subtract 6 on both sides in this vertical way, it's sometimes helpful to put a line as if you're doing a regular old addition and subtraction problem. X plus 6 minus 6 there. Plus 6 and minus 6 cancels out completely, becomes 0. It's called the inverse property of addition. So you just get x over there because it's x plus 0, and 15 minus 6 is 9. Easy enough. This one's a little bit different, this number 2, mainly because of the negative on the x there. There are a couple of ways to do this question. I'm going to show you my favorite way to do the problem, as well as the way it was taught in class. I'm going to do the way it was taught in class first. We're going to go ahead and add x to both sides of the equation. The reason why is that this will force x to become a positive number. As you notice, I've done this problem horizontally, left to right, instead of up and down. Sometimes horizontally is better, sometimes vertically is better. You'll have to make your own decision. Negative x plus x, that cancels out. Therefore, you get 7 is 12 plus x. And now it's just like the previous question. We'll subtract 12 on both sides. So in addition to subtracting 12, I could always add negative 12, or I just go, oh, negative 12 there, negative 12 there. It's kind of a benefit of doing it horizontally. Negative 12 plus 7 is negative 5. 12 minus 12 is nothing, and you just get x. Now I said I was going to show you how to do it my favorite way. My favorite way is a visual way. What we're going to do is we're going to take this x right here, and to make it positive, we're just going to go ahead and move it to the other side of the equation. Anything that's on one side, negative, is a positive on the other side. Just like so. After that, we have this positive 12 here. You can even put a plus sign in front of it to remind you that it's positive. And if you move it to the other side, it becomes negative. So negative 12 plus 7 equals x, just like we had here. And you get negative 5. Please note you could have also written 7 minus 12. You'll get the same answer. Let's continue on. I'm going to go ahead and do this question horizontally again. Divide both sides by negative 3. Why are we dividing? We're dividing because this is multiplication. So a common misstep that students do is they see, oh, it's just like these two problems, and if I add 3 to both sides, I'll be good to go. But you don't. And the reason why is because this is negative 3 times x. So to undo multiplication, we have to use division. So we divided both sides by negative 3, and therefore we get x equals negative 5. Likewise, on problem 4, this x divided by 5, to undo dividing by 5, we multiply by 5. Multiplying both sides by 5, it ends up being that 5 and 5 cancel out. And I'm getting x equals 30. In the next step here, next problem, we have a fraction. Whenever you need to get rid of a fraction, we're going to multiply by the reciprocal. I'm going to need to write this on the next line because I don't like that negative sign. It's kind of in the way for me. So we have a negative 2 over 3. The reciprocal is the upside down of the fraction. So we're going to multiply by 3 over 2 to make x alone. Specifically, negative 3 over 2. So if you notice, I put a negative 3 over 2 on both sides. When this happens, the 2's cancel, the 3's cancel, the negatives get multiplied by each other and become a positive. Everything goes away and you get just an x. And on the right-hand side, we're going to multiply across the top to get negative 15. Multiply across the bottom, we get 14. And that's the whole question. Now, on question 6 here, I feel like the camera's blurry on that problem for some reason. We'll try to fix it. There you go. That fixed it. Oh, actually, it makes everything prettier. Huh. All right. Anyways, so we're going to go ahead and multiply the top and bottom of this problem by 25 over 12 is the multiplication here, because we're trying to get rid of the fraction next to the x. So we're multiplying by 25 over 12, multiplied by 25 over 12. And you just get x on this side, but what happens over here? Let me write this again, because it's kind of scrunched up and ugly right now. Now it's not so bad. Whenever you have a fraction multiplication, we can do what is called cross cancellation. There's actually another way to do it too, so I'm going to write this again just in case I want to do it the second way. So to do cross cancellation, we ask ourselves, is there a number that goes into both 25 and 5? And the answer is yes. We can divide both of these by 5. Now we look at the other diagonal. Is there a number that goes into both 12 and 4? The answer is yes, 4. We can divide them both by 4. 25 divided by 5 is 5. 12 divided by 4 is 3. 4 divided by 4 is 1. 5 divided by 5 is 1. And therefore x is just 5 over 3, because 5 times 1 is 5 and 3 times 1 is 3. Over here, on this side, we have 25 multiplied by 4 on the top. If you want to do it this way, we can multiply across the top and get 100 divided by 60. 12 times 5 is 60. A cute little trick you can do on fractions like this is anytime they end in 0, it means they're both divisible by 10, and you can kind of just cancel out the zeros there and you get 10 over 6. And then you can notice that both of these numbers are divisible by 2. So I'm going to divide by 2, divide by 2, and I get 5 divided by 3. Either way, I get the same exact answer. Let's work on to problem number 7 now. So problem number 7, we're going to use that distributive property. We're going to take the 2 to the x, the 2 to the negative 4. Now, be careful here. With this distributive property, we're doing negative 3 to the 2x to get negative 6x, but negative 3 times negative 2 is positive 6. After this, we have to add like terms. So here we have a 2x minus 6x. Those are the same type of terms. They're alike because they both have an x. And 2 minus 6 is negative 4. Don't forget your x on there. In class, we kind of did an underline of these guys. Now, negative 8 plus 6, those are the other two like terms. This is going to get you negative 2. Once you get to this step in an equation, you have to use reverse Pemdas. So reverse Pemdas, in this step, backwards Pemdas ends with subtraction, so we're going to go ahead and have to use the inverse of subtraction, which is addition. We're going to add 2 to both sides. Now, these guys cancel, and we're going to get negative 4x, but these guys also cancel, and you just get 0. And now we have to divide both sides by negative 4. We have to get that x by itself. And our final answer is x equals 0. 0 divided by anything is 0. There is an exception. 0 divided by 0 is different. You can ask me about that if you'd like to. Now let's look at problem number 8. Problem number 8 is weird because there's an x on both sides of the equation. So we need to go ahead and subtract the 4 on both sides to get the 4 over here. That's going to give us 3x equals 7x minus 16. So similar to this question, when we move that added the 2 to both sides, we're doing the same thing here. But now we also need to subtract 7x on both sides. The reason why is this cancels out completely, and you're just going to get negative 16 over here. And 3 minus 7 is negative 4. on that x. And now I can divide both sides by -4. And I get x equals +4. -16 and -4 is +4. Easy enough. We are almost done with this page. Problem number 9. We need to go ahead and use our distributive property again. We have 2x multiplied by 3x and 2x multiplied by -2y. So 2x multiplied by 3x is 6x squared. That's because we have an x times an x. 2x multiplied by -2y is -4xy. That's not too bad. After that, we have -3y times 5x. It's going to be -15x. Y. No, it could have been yx, but xy and yx mean the same thing. So I'm always going to put alphabetical order here, so I'm putting the x first. If you put yx, you're completely correct still. It's not wrong. Then we're going to do -3 multiplied by -5, and that's going to give us +15. And then we have a y multiplied by a y to give us a y squared. Finally, we have to add like terms. The 6x squared doesn't have any like terms, so we can leave it alone. -4xy minus 15xy, though, those are both like terms. We can kind of underline them if we wanted to. -4 minus 15 is -19xy. After that, we just copy that last 15y squared and we're done. Number 10. Number 10 has all multiplication. Multiplication has a property called the commutative property, or the commutative property. That's a hard word to spell. Commutative. So commutative means it goes in both directions. Like communication, you can commute both ways. So commutative property means you can multiply in any order that you want to. So this whole thing right here, 5x, 3x, 2x cubed, x squared, you can rewrite if you wanted to. You don't actually have to write this step down. Optional, write this step. You can write this as 5 times 3 times 2 times x times x. Notice I'm just putting the 5, 3, 2 first, and now I'm doing the x and the x and the x cubed and the x squared. Whew, all right. Basically what I'm trying to say is you can just multiply the numbers together first. 5 times 3 is 15, and 15 times 2 is 30. You just multiply by the x's. How many x's do I have? I got 1, 2 there. Remember, x cubed means x, x, x. That means 3 x's. And x squared means x, x. That's 2 x's. So I have 1, 2, plus 3 is 5, plus 2 more is 7. I got 7 x's. Easy enough. Question 11. It looks long and daunting, but it's actually not that bad. Step 1, remove those parentheses. There's actually nothing to distribute and nothing special about these parentheses at all, so we're just going to take these guys away completely. But here we have a negative sign that we have to distribute. That negative needs to go here, and here, and here. It needs to go to all 3 guys. So minus 2x cubed minus x. Notice how that sign changed, and this sign here is also going to change, going to become a positive 5. That is the effect of distributing a negative sign. After that, we need to distribute this 2. The 2 goes to the 3x cubed, and it's going to become 6x cubed. This 2 goes to the 4 to become an 8x. The 2 goes to the negative 5 to become a negative 10. And this minus 3x is all on its lonesome. Just copy it down. After that, I'm going to do it differently than the underline method we had done in class originally. I'm going to teach it a way that was really working for some other students after school. So off to the side, I'm going to start by writing down the highest ordered exponent, in this case, a 3. If you remember from this week's lesson, that means it has a degree of 3. So for my third degree, I'm going to write down the coefficients of all the variables. Remember, the coefficient is the number in front. And for the very first x cubed, there is no number in front, which means there is an invisible 1. Once I've taken care of a variable, in this case the coefficient of 1, I'm going to go ahead and cross it off. That reminds me that I've already used it. Now, I'm going to move on to the second one, which is negative 2x cubed, so minus 2. Cross that off. I'm going to keep looking for an x cubed. Oh, I see an x cubed right there. So I got a 6x cubed, so plus 6, and I'm going to cross that off. I have no more x cubed, so now I can move on to x squared. So x squared, I got a 3 right there. Took care of it. I'm going to keep on looking, keep on looking, keep on looking. Oh, the last one, minus 3. Now I'm going to write x. Remember that x means x to the 1, so if you want to put a 1 there for yourself, you're allowed to, you don't have to. 2x, oh, right away. Cross that guy off, look for another x. Oh, I see one, negative 1. Look for another one. Oh, right there, that's 8. Easy enough. Then we got 2 more numbers. I'm just going to write a little squiggly line because there's no x's at all for those. So 5 minus 10 is negative 5. Let's see what these numbers add up to. You can use a calculator, of course, if you'd like. But 1 minus 2, that's negative 1. Plus 6, that's going to give you positive 5. 3 minus 3 is 0. 2 minus 1 is 1. Plus 8 is 9. Oh, and I forgot to write this. Ooh, I'm sorry, guys. I kind of did this part in my head. I meant positive 5 here, minus 10, and that gives you negative 5. I apologize. So I use the 5, cross that off, the negative 10, cross that off to get the negative 5. I apologize for going too fast there. Anyways, to finish this question, I have 5x cubed, so I'm going to write 5x cubed. I have 0x squared, so I don't have to write anything. I don't have any of those guys. And then I have a single x gives me a 9 on there, so I got 9 x's and then minus 5. Not too bad. Number 12, x to the 5th cubed. There are 2 ways to do this. The hard way to do it is writing this. Why did I write that? Because that means I have x to the 5th 3 times multiplied by itself. That's what cubed means. It means multiplied by itself 3 times. So here, this guy, x to the 5th, that is x times x times x times x times, that's 5 x's. And this guy means times x, 1, 2, 3, 4, 5. And this guy means 1, 2, 3, 4, 5. How many x's do I have? 1, 2, 3, 4, 5, blah, blah. If I add them up, I get 15. X to the 15th. There were 2 easier ways to do this. First of all, I could have just done 5 plus 5 plus 5 to get me 15. Or even easier, 5 times 3 gives me 15. I could jump right to the answer on this one. I don't have to do nearly as much work. Same concept on number 13. 2x cubed. That is the same thing as 2x times 2x times 2x. And this 3x to the 4th squared means 3x to the 4th times 3x to the 4th. And 2 times 2 times 2 is 8. X times x times x is x cubed. 3 times 3 is 9. X to the 4th times x to the 4th. Well, how many x's is that? That's 8 x's. So I can get x to the 8th. 8 times 9 is 72. And x to the 3rd, x to the 8th, that is 11 x's overall. Not too bad. We are done with this side. Let's go to the back side now. Evaluate. So remember, evaluate means give me a number. So both of these questions, they want a single number for me. So it says if x equals negative 8 and y equals positive 3. So let's go ahead and substitute. If y is 3 and x is negative 8, notice how I'm just replacing that y with the 3, that x with the negative 8. This y right here is a 3 minus absolute value bar 2 negative 8 plus 4 divided by, and there's no substituting here, so I can just like multiply this out. 1 squared, that's 1. 2 to the 1, that's 2. After that, we need to kind of do more work here, and I'm kind of running out of room, which is not so good. So I'm gonna do an oopsies, and I'm gonna go this way because that's my bad, running out of room here. Not supposed to work in this direction, but my fault for not giving you guys enough room here. 3 times negative 8, that's negative 24. 6 times 3, that's 18. 2 times 8, that's negative 16. 1 times 2 is 2. Negative 24 over 2 is negative 12. 18 here minus absolute value of negative 12 all over 2. I'm still running out of room. I still got to keep going, so sorry about that. We're just simplifying as much as we can. Remember, we can use a calculator any one of these steps. Negative 12 plus, and now we have 18 minus, and what does absolute value do? It means it turns something positive, so that's minus a positive 12, still divided by 2. Negative 12 plus 18 minus 12, remember there's invisible parentheses. 18 minus 12 is 6 over 2. Finally, negative 12 plus 3, which is negative 9. That was a long question. Oh my. Number 15. Got to plug in negative 2 for b. So h of negative 2 is, and we're replacing that b right there, because this is h of b, with a negative 2. So if that b became a negative 2, that means these b's over here become negative 2's. After that, we're just going to go ahead and do some math here. Remember, this is multiplying right here, and you have to multiply before you subtract, so you can't deal with this subtraction until you've multiplied. 2 multiplied by negative 2 is negative 4 minus 4. Just copying. Negative 4 minus 4 is negative 8. The absolute value of negative 8 is positive 8. Negative 2 times 8 is negative 16. And if you have a negative of a negative, that means positive. So that's going to be 3 plus 16, which is 19. That's what h of negative 2 is. Now, I'm not going to write down vocabulary for you guys. I don't think you need me to. You can copy it from your notes, from your notebook, from something else. If you truly don't know one of these vocabulary words, please ask me during class. I will help you out. Hopefully this video was helpful, and good luck and have a good weekend.